Find the area of the region bounded by the graphs of f of x equals 3x cubed minus x squared minus 10x, and function g of x equals negative x squared plus 2x. First, I'm going to set these two functions equal to one another. This will be at the top right of your screen. Function f set equal to function g. Bring all your terms to one side. You can factor out a 3x. That leaves x squared minus 4. X squared minus 4 is a difference of two squares. This gives us three factors with a variable. Setting each one equal to 0 and solving, we're going to get 0, negative 2, and positive 2. You can pick either function to substitute those x values in to get the y value at the intersection points. We know that these three x coordinates are intersection points. Pick the easier of the two functions to sub into to get your y value. G is easier to work with than f, so that's why I chose G. Substituting each of these x values into G, G of 0 is 0, G of negative 2, if you sub in, you get negative 8, and G of positive 2, sub it in, you get 0. That tells me I've got intersection points at the origin, negative 2, negative 8, and also at 2, 0. Let me scroll a little bit. If you look at the diagram at the bottom right of your screen, function f is the red function. That's our cubic. Function g, that's the blue one. That was our parabola that opened downward. Notice at negative 2, negative 8, 0, 0, and at 2, 0, those matched our intersection points from our previous calculation. Going back and trying to find the total area between these two curves, between negative 2 and 0, this little shaded region, f of x is above g of x. And so we'll have to be careful to subtract that f minus g, but only from negative 2 to 0. So that's what I've got here. The integral from negative 2 to 0, f of x minus g of x. Between 0 and 2, function g is greater than function f. So I'll have to reverse my order of subtraction for that one. Between 0 and 2, g is greater than f. Function f minus function g, combining like terms, minus g of x. Be careful, sometimes you'll have back-to-back negatives. So we have function f of x minus function g plus, now the order is reversed, g of x minus f of x. Doing the algebra behind the scenes, for the first bracket, we get 3x cubed minus 12x. We're going to integrate that negative 2 to 0. And then this second bracket, when you clean all it up, you get negative 3x cubed plus 12x. Notice the signs are backwards. And we're going to integrate that from 0 to 2. Okay, let's integrate. That's 3x to the 4th over 4 minus 12x squared over 2. That's 6x squared. Substituting in a 0 followed by a negative 2, subtract, that gives you 12. This has an area of 12. The other integral from 0 to 2, we integrate negative 3x to the 4th over 4 plus 6x squared from 2 to 0. Subbing in 2 minus subbing in 0 gives us 12. Even though it doesn't look like it, these two sections have equal areas. Total area, 24 square units. Let's look at a case of horizontal representative rectangles. Find the area of the region bounded by the graphs of x sub r, 3 minus y squared, and x sub L, y plus 1. Now, if you were to look at the graphs, this graph is always to the right of this one. When you set them equal, put all your terms on one side, you get y values of -2 and 1. Let me switch to the next slide. Pause here if you need to write that down. Okay. So over to the right of your screen, excuse me, we have the one I called x sub r. That's a left opening parabola. X sub L was the linear function, y plus 1. If you use horizontal, this little red strip is a horizontal representative, you want the right function minus the left function. If you do it with respect to x, you want top minus bottom. But see this little section? That's an overlap, and we don't really have a top and bottom there, but we always have a right versus a left. We're going to be integrating with respect to y. The y values at the intersections are -2 and 1. So be careful, we're going to use y values this time. Integrating from -2 to 1, x sub r, that's the right graph, minus x sub L, that's the left graph, parabola minus line. Collect all your like terms, we get -y squared minus y plus 2. Now let's integrate. -y cubed over 3 minus y squared over 2 plus 2y. Substitute a 1 in, and we get 7/6. Minus, substitute in -2. We get -10/3. Combine like terms, basically you're just going to add these two fractions together. 27/6, which equals 9/2.